I saw CPD there, free CPD. So
you get one.
yeah.
Okay. Good evening, everyone. It's 6 p.m. So we just have to start. We have other people in the house. We have Esan. Esan, can you say hi? So I will.
Hello, salam alaikum.
Malaikum salam, Esan. Welcome. Other people are joining. So let me welcome others. Yeah, Vibin has joined us, so we'll just welcome people that have joined so that we know who and who is here.
Thank you so much. I just joined. I don't know what's happening before.
Yeah, Vibin, you're welcome. I think you were on mute before, so now we can hear you now.
Yes, I have some network issue here. That's why I just log out and now I log in again.
All right, you are welcome. Are you in Doha? Are you in Qatar?
Yes, I am working in Qatar.
Okay. Welcome. We're happy to see you. All right, we are starting. I think everyone here knows me. My name is Johnson Wala, and I'll be coordinating the discussion today. Like we all know, our topic today is confined space entry. So we'll be talking about confined space entry, and everyone will contribute. I'll just introduce the topic in about 5 to 10 minutes. Then I'll give the opportunity for others to contribute and give their own knowledge or ask questions so that we all learn together. So it's not a forum for someone knows it all. Nobody knows it all. So that is why we are here today. All right. So confined space entry. There are different people have different definitions for this, but majorly we have 3 major criteria for identifying a space as confined space. One is that it's large enough or is configured for an employee to enter, and it has limited opening for entry and exit, and is not designed for continuous occupancy, meaning it's not designed for somebody to stay there for a long time. So these are the major criteria for defining a confined space. So it's, in most cases, it must have these 3 criteria, then you conclude it's a confined space. In a bit, we'll get to a space where we'll start judging if a permit is required or not to enter the confined space, depending on the criteria. All right, these are typical examples of a confined space. Some boilers, furnace, pipe, manhole, sewage, septic tanks, trenches. So these are all examples of manhole. Depending on the industry where you work, you will have a lot of examples and different scenarios. Okay, those in the construction industry, you will be more conversant with manholes. You'll be more conversant with shafts. So these are examples of confined space. If it has limited access to entry, it's not designed to stay for a long time, and the exit and entries are limited, so can classify it as confined space. Okay, now in categorizing confined space, I hope you can see my screen, right?
So,
Huh?
yes, yes.
All right.
Yes.
So in categorizing confined space into permit required or non-permit required confined space, you have to take note of if the space is large enough to enter, there is limited or restricted entry, and if that space is not designed for continuous worker occupancy, then it's a confined space. Now, for you to determine if a permit is required, either of these or all these criteria should be available. Like if the environment is hazardous, if there is hazardous atmosphere, if there is possibility of engulfment, there are configuration hazards, like there could be overflow or there could be drowning, okay? And there are other recognized hazards, like oxygen deficiency or over-enrichment. So if these hazards are present, then permit to work is required. So it's a permit confined space, okay? But if these hazards are not present, then it's a confined space, but you can say that it's a non-permit required space. Okay, that is, it could be argued is depending on the industry and depending on the workplace. Okay, some workplace will say that every confined space is permit required. So we'll discuss about that in a bit, depending on your industry. We can hear from you and know how you implement permit to work permit in a confined space. All right, so what makes a permit, what makes a work confined space limited access? If the opening is like 18 inches in diameter, or if there is a difficulty of entry with safe breathing apparatus. Also, if it's difficult for, if it's very difficult for you to remove people from the confined space, maybe in the event of emergency, if it's difficult to remove people, then you know that there is limited entry. It's a limited entry space. If there is difficulty for people to bend, somebody that is working inside there, if it's difficult for him to bend down to do his work, then there is limited exit and entry. So these are like checks. These are like criteria that you can use to check if this space is limited opening, if it has a limited entry or exit. Okay, then how do you now check if the environment is unfavorable? If there is lack of air movement and if there are decomposed organic materials, you can say that this is an unfavorable environment. Okay, so what we are looking at now are checks, points that you look at to conclude if this confined space is requires permit to enter. All right, then how do you now confirm if the place is not designed for continuous occupancy? If there are equipment stored inside that location, if the location is meant for repair or maintenance activity, then you know that it's not designed for continuous occupancy. It's for temporary activities, just for maintenance. There are equipment stored there, and it's used for storing materials. It's maybe it's a tank. So it simply means that it's not designed for human continuous occupancy. So it's a confined space and it requires permit to enter. So these are the points that you use to check. Now, another point that you use to check if there is dangerous combinations, like if there is presence of all the characteristics of a confined space, okay, and if there is possibility of complication during rescue operation, okay, if the activity that will be going on there involves welding, it involves hot work, or maybe there will be use of gases or hazardous substances, then you know that the environment is dangerous. There's dangerous combination. So there is need for permit to work. Okay, these are some hazards that we'll find in confined spaces: oxygen deficiency, oxygen enrichment, flammable atmosphere, toxic atmosphere, temperatures, extreme temperatures, either extreme cold or extreme hot, engulfment hazards, noise. Okay, what do we mean by oxygen deficient environment? If inside the confined space has oxygen below 19.5%, then we know that that environment is deficient of oxygen. So it's hazardous and it should not, it's a confined space and it's a hazardous environment. All right, if the oxygen level also is above 21%, of course, you know you are going to do gas testing. So we'll come to that. But if you do your monitoring, your gas testing, and you find out that the oxygen level is above 21%, then it means that that confined space is oxygen enriched. It simply means that the oxygen level is very high and there's possibility of fire outbreak inside there. Okay, now flammable atmosphere. If the oxygen contains, if there's air, if there's presence of flammable gases, okay, if there is smoking, if there's welding operations going on inside there, then it's a flammable atmosphere. Toxic atmosphere. If the gases are released, if there are decomposed materials, so these are all toxic atmosphere, and there is adequate control measures should be in place. All right, if there is a presence of hydrogen sulfide comes from decomposed human waste, and it smells like a rotten egg. So there is possibility of no warning at high concentration. Okay, so if the hydrogen sulfide is present in the confined space, then is a hazardous atmosphere. Carbon monoxide, if carbon monoxide is available in the confined space, then it's very, very hazardous. All right. We talked about extreme temperature before. Engulfment hazards. If there are loose soils, or maybe there is a possibility of flooding, or there is a sewage, or there is a sewer flow, then that is an engulfment hazard in confined space. Noise, falling objects, these are all hazards in confined space. What you see on your screen is a typical example of a confined space where you see that there is limited space to enter and there is limited exit. All right, before you start any activity in the confined space, there must be testing. You must test the environment, and testing must be done by a competent person, authorized gas tester, who conduct the testing in the confined space. And while testing the confined space, he must test both the top, the middle, and the bottom of the confined space. The reason is different gases settle at different levels. Like methane is lighter than air, so you are likely to see it on the top. And carbon monoxide is at the same level of the air. Hydrogen sulfide is heavier than air, so you are likely to see it at the bottom. Okay, so while conducting gas testing, the authorized person must conduct the gas testing properly. If not, he might conclude that the confined space is safe, whereas at some point it becomes unsafe. That is why in most cases they use the tube type. You have the tube that will insert in the confined space that will be able to get you the reading at the top level, the middle level, and the bottom level, so that you'll be able to conclude that the entire levels of the confined space is safe before entrance. All right, ventilation. Confined space must be properly ventilated. If there is poor ventilation in the confined space, then it's not safe to walk in. Then it must be properly, air intake must be properly be drawn. Fresh air should be sent to the confined space, and another gas testing should be done after it has been ventilated to confirm that there is adequate ventilation before entering. Isolation. Before entering into a confined space, all the energy sources should be properly isolated. Last week we discussed lockout tagging, so there should be proper isolation, locking, tagging of the equipment, energy sources in a confined space before entry. Respirators. Respirators must be used in the confined space where there are possibility of hazardous substances and contaminated air. Okay, we have air purifying respirators and air supplying respirators. Air purifying respirators are used to filter dangerous substances from the air, while air supplying respirators are used to supply breathing air from a tank of uncontaminated tank. Permit entry system. So for every confined space, a permit to walk should be raised. Permit to walk raised cannot be used to walk in a different confined space. So each confined space should have its own permit to walk and should have a separate supervisor and a hold watcher, somebody that is keeping a watch and taking record of who is entering the space and who is coming out. Okay, the confined space permits must have a record of the people walking inside there, must have record of the time, the date, the location, the activity going on there, and the identified hazards with adequate control measures. Okay, we've talked about the entry requirements for permit to walk for confined spaces. Okay, the people entering inside the permit, inside the confined space must be trained. They must be trained. The entrant must be trained. The authorized gas tester must be trained and competent. The confined space supervisor must be trained and competent. So different levels of training for the people. Standby or rescue. I've talked about a manhole watcher. He must be present from the beginning till the end of the activity. He must be present, watching the hole, keeping a communication with the people inside the confined space to ensure that they are working safely and they are okay. All right, confined space rescue training. if there is a confined space in the workplace and people are working inside the confined space, there is need for confined space rescue team. Okay, and before they should be authorized, then they need to be trained. They need to have all the necessary equipment to conduct a safe rescue in the confined space. Okay, I would like to stop here because of our time, so that other people can contribute and discuss. If there are questions from the slides that I have not discussed, then we can go back to it. I don't want to be the only one talking today.
Can you give me access to share my screen? I just have one or two.
Yeah.
I just want to go through the slide. Yeah.
Yeah, I've given you access. Try to share.
Okay. 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 For those that don't know me or that are attending this workshop for the first time, I'm Stephen Francis by name. I'll start by saying Mr. Johnson has really said lots about what confined space is all about. But why I decided to bring in my slide is because my slide is full of a lot of graphics, you know, so that at least we could just refresh our memory with all the stuff that we know about a confined space. Okay, and one basic thing we should know about confined space entry is to ensure that there's a safety in an what's it called, a hazardous environment, because a confined space environment is an hazardous environment. So what's our purpose or our function as a professional is to ensure that there is safety within such an operational environment. Okay, so now when you look at the slide, you find out that this confined space, they exist in different forms, just like the way Mr. Johnson has earlier said. Okay, we have different forms. They can come in the form of storage tank, crawl space, pipeline, silos, boilers, and all that, and so on and so forth. Basically, it depends on the industry you work. Okay, like he said, in the construction, which most of us work, you might find a shaft, you might find a trench, you know, you can find a manhole, and these are just the basic common ones we find in the construction. But when you start going to the process industry, those managing the environmental area as well, you begin to see things like pipeline, tanks, furnace, boilers, and all that. So I think in this industry, confined space is a very, very critical and one area that people don't joke with, you know. So everybody are designated to carry out certain function in this area of confined space. But I know we might just ignore a lot of things in the construction. Then when we look at recognizing confined space, okay, like Mr. Johnson has said earlier, these are common things that we know. A confined space are associated with a limited or restricted entry or exit points. And because of this limitation, there is the tendency, there's a 99% tendency of poor ventilation, okay? And because of how confined this environment is and what it contains, can present an hazardous substance or condition within such an environment. Okay, and also we all know that this space are being configured, they have this configuration issue because naturally they are not designed for human occupancy. So you are likely to face all this kind of issue or hazard. And also one of the things you can also use to recognize the confined space is that there's likely 99% of poor illumination as well. Okay, so now, like he has rightly said, we have some series of hazards that we could see present, you know, in the confined space. Like Mr. Johnson we have seen from the slide, okay, we are familiar with oxygen deficiency or enrichment, which is one of the first things we just have to start checking for, okay, and also some other chemical or toxic gases that are present within the environment. There could be flammable, explosive atmosphere as well, which Mr. Johnson has highlighted. I'm just trying to run through this so that we'll just have a kind of pictorial discussion about what we are talking about. So, and also you can have some kind of physical hazard, which could appear in the form of heat stress, okay, and also noise, vibration, and also some hazard as a result of electrical equipment being present within the environment. Okay, so, and also this limited access and egress into a confined space is an hazard on its own. So we should also take note. Then when we look, we're talking about the oxygen level and all that. We could see from this chart here that at every point of the percentage of oxygen you can find in such a confined space environment, you can see what can really happen. Okay, when you have it at normal level, which is 21%, I think everything is good. But when you go below, when you get around 16%, you begin to have judgment and breathing impairment. Okay, so even at 10%, you have loss and consciousness. Then 6%, this will lead to death within a second. Then above 21%, when we get towards 23%, any little thing that has to do with spark, you know, will trigger fire. Okay, and even at the level of 40%, just normal oil and grease will ignite. So it's all those things we just look uncommon are very critical issues when it comes to confined space. Now, I just want to bring us to some basic procedures that we should all be familiar with when it comes to confined space activity, because the first step is that we have to carry out what we call evaluation. Okay, in that evaluation, we have to determine if actually this environment is a confined space, or like what Mr. Johnson has said, this space, does it require a permit or is a non-permit required space? Also, we have to identify the hazard within such an environment, and we need to develop a plan, an entry plan. Okay, then the second stage, we look at the preparation. In this preparation, there we'll talk about the testing and monitoring of the atmosphere. We ensure that there's sufficient ventilation, proper illumination, and also established means of communication, which is very, very important. Like you will see the graphics that is here. This is a gas monitor or gas calibrator, in whichever way we want to put it. Now, when you look at this chart here, you see, just like as Mr. Johnson has said earlier, you don't just test the air at the surface level. You have to go deep down to the base, because the most deadly air is at the base, at the bottom. Then at the middle, we have a poor air. So if you just test at the top, you will definitely get a good air. You understand? So, but you need to go down, deep down beneath the confined space to determine the level of oxygen and other gases that are available within the environment. So another point of this entry procedure is that we need to look at entry, which is to ensure implementing a confined space entry permit, which we have mentioned earlier. And in some cases, you go into a confined space, you will need another form of permit, because in the confined space, you might be carrying out some hot work activity, it could be cold work, and some other kind of activity that might require an additional permit to take more precaution. You know, like I've said, communication is very important. You need to have a protocol for entry and exit. You need to have a confined space entry supervisor, well-trained and competent, and also an attendant or a hold watcher who is going to be in charge of taking attendance of those who goes in and enter a confined space, and also be communicating with those who are working within a confined space by either looking at them physically or communicating through radio and all that. Then one other important aspect that we must consider in a confined space is that there must be, before you embark on any activity of a confined space, there must be rescue and emergency procedure or plan being established, okay, and the equipment available. And part of the training and education is that we need to have what we call, we need to conduct a kind of emergency drill, you know, for a confined space activity, so that those workers who work within such an environment will be familiar with such training. Okay, and there are always a safe practice, you know, which we must always carry along as a professional. We have to look at assigning a competent and a trained supervisor, like I've said earlier, and a watcher, ensure that they are adequately trained, implement the permit to work system, you monitor and maintain the equipment, the rescue equipment. They're also very important, because if you don't maintain them, you want to use them for rescue, it's like you are doubling the hazard. So we also try to ensure that we review and update our safety procedure, our general confined space procedure generally. Okay, so, and a lot of precaution that must be taken into consideration, just like as Mr. Johnson have said. There should be a lockout target procedure for equipment in or near the confined space. Okay, we ensure adequate lighting and signage within the environment, and ensure not to use tools that can create spark. Okay, so we try to make use of tools that are non-sparkling tools. So we have to secure or guard the opening, because every confined space has an opening. Like if you look at the picture around here, you could see something like this. So sometimes you have to do a kind of barricade, you know, to make people aware of the environment they are working. And also, like I've said, training and education is very, very important. If you don't train your workers, your staff who are working within such an environment, then we are creating, should I say, a death sentence to those workers. So it is advisable. We know how important training could be when it comes to safety. So they are very, very important. They have the knowledge of entering into a confined space. They should have the knowledge of emergency procedure in case there's emergency. Also drilling, you know, carry out drilling, training about how to carry out drill is very important. Also communication, like I've said, if you don't have an open communication, there's going to be an hazardous environment. So when we look at all these things, like I've said, we can come in a conclusion to say that confined space require careful planning and adherence to safety procedures and protocol, and also to understanding confined space entry hazard and implementing the proper precaution is a very crucial and very important aspect within such an environment. And like I've said, training, communication, these are things we don't just joke with. We must be able to implement them to have a successful confined space work activity without having an injury or an accident. Thank you very much. Hello?
Yes, thank you very much, Mr. Steve. We appreciate your contribution. And Sandro, are you there?
Yes, good evening, sirs. I'm here with you.
Okay.
Yeah.
Are you ready?
Yes, let me just contribute little, because you guys have said it all. Yeah, it's really amazing. Thank you for the wonderful presentation. Yeah, what I will just contribute is the implementation aspect. The implementation aspect of the confined space, the duty of the safety profession, because we are at the center of the whole implementation and enforcing the rules. So one of the challenges that we face regarding confined spaces, actually, sometimes workers taking shortcuts. Sometimes you may not be aware that they are going to work in the confined space, and when it goes wrong, they come after the health and safety, because they believe you are supposed to know that workers are working even without you being informed. So these are our common experiences. So what do we do? Yeah, we have to draw management commitment. We have to remind them of the implication and the implication of the hazard or possible accident that we occur or that might occur in taking negligence when it comes to confined space working. Just as Steve has said, it's not something to joke with. In most of our sites, we have a lot of confined spaces, and sometimes the management will tell you this is not confined space. It may be safe today, and the next minute it's not safe. Are you hearing me?
Yes, yes, we can hear you.
Am I audible enough? Yes, yeah.
Sure.
So it is a dangerous situation where you have confined spaces. Sometimes, like in the construction, we may have a lot of manholes, and they will tell you it's just a little work they will do there. They don't need to follow procedures. Sometimes we know we have to be we have to come to that level where we're able to convince management of the legal requirement. The legal requirement as per the standards when like the OSHA standard in general are coming to our own local level here in Qatar, we have QCS. We have to draw their attention what a confined space attain at what limit we can consider what is confined space, at what depth. Just we have the general understanding of the confined space that it may be a very big hall, yet it's a confined space. The layman will look at it that this place is wide enough, it's big enough. So how can you say it's a confined space? So we should be able to bring to their understanding that even if the place is so wide, there may also be possibility of hazardous substances generated because of the kind of job that will be taking place there. And besides, because of the enclosed nature of it, there's no inflow of air as usual. So all these are challenges that we face every time. And besides, in a confined space, maybe in an underground tank or storage system, where you have other connections, pipes, the management team or the people, the engineers and the workers that we have to work there may not understand the as per build drawing of that particular structure, where you have interconnecting pipes or even sometimes utility pipes like gas may run through that area. And there could be an inflow of gas without anybody knowing. So all these things we have to consider, we have to check, we have to construct, and we have also to make sure that we identify all the confined space in our workplace. I will give, for example, in my own experience, where I worked before, when I counted, I tried to take an inventory of all the possible confined space in our workplace. I count more than 100 plus. More than 100. How do you cope with that? And you have these workers everywhere, from different both subcontractors, both that they are all going in, working and coming out. It was a chaotic situation where you can just get confused of the whole thing because you don't know what to do at that time. So we have to make sure that we take the inventory to know how many possible confined space do we have on this project. Then what do we do next? Our risk assessment, just as you have, all of the speakers have highlighted, planning is very important. We have to make sure, because when we identify all this and we identify the possible hazards that are in the confined space, we can plan accordingly. And the good thing is that same process can apply to all. How possible can we as the health and safety professional, be able to convince this management that, look, nobody must work inside any of this considered confined space without following the procedure. That is the challenge. So at the time, they will not want to provide the necessary equipment that is needed because management always want to cut costs. They always want to cut costs. And they will see us as a barrier to company spending money. But we have to convince them that if we don't follow this procedure, if we don't buy this equipment, if we don't provide the training, if anything happens, that will be like times 20, times 100 of the cost that the company could have incurred. That is what we generally say that we're trying to save money. At the end of the day, we are at loss. So we must be able to convince management the return of investment on the business if we implement these procedures. So we have had an experience on that level. That is why I'm bringing it in. So at the end of the day, management will see reason and they will provide this, and we will have a better site where we will not have a disastrous situation where workers die. We all know of the case studies in our local environment here in Qatar. People lost their lives. Some are known, some are not known. So it is something, just as Mr. Steve said and Mr. Johnson and every other speaker have highlighted, we have to make sure that we don't take chances when it comes to confined space issues. All the procedures, all the standards, and all the legislation that follows, we must bring to management attention that they should look at it. And I believe in you, when they see the implication and they see the hazard, you'll be able to convince them through this legislation and standards that are involved. They will buy in. They will buy in, no matter how difficult the project manager will be. It will buy in, and we provide the resources, the budget for the confined space entry safety implementation. That is it for my side. Thank you very much.
Thank you very much, Mr. Andrew. We appreciate your contribution. Indeed, there is nothing much anyone can do from the implementation if the management does not buy the idea of the situation. So the first approach is to bring the management on board. The senior management must be on board. That is why we thought about training. It's not just the entrants that needs to be trained. The management, the supervisors, the managers, the engineers, they need to have an idea of what could happen if proper control measures are not put in place. Because if we just train only the people that are going, that will be working inside a confined space, it's good they have the idea, they have the information, but someone is making all the decisions on their behalf, which is the management. So the management need to be aware of the hazards and the hazardous situations of the confined space so that they will be able to make appropriate provision for the resources required to ensure that the confined space is safe and the people work safely. Okay, Mr. Stephen, your hand is
yes. Yeah, I would just like to make just buttress more on what Mr. Andrew has said. You know, for most of us that are at the level of our profession, especially when you are talking about somebody who is a graduate member of IOSH, somebody who has a status of CM IOSH and all that, within all this professional body, I think for us as a professional, for us to have attained this height, we have this responsibility, you know, to communicate with our top management, just like Mr. Andrew have said, because most of these people, these are not their field of expertise. And they know little or nothing. Okay, that is why even within the IOS, they begin to design some courses which can be introduced, to management, those people who are not in health and safety, for them to be able to have this basic knowledge of these things we are talking about. Because the truth of the fact is that in our own side as a professional, and at the level that we have, we need to be able to understand what we call cost-benefit analysis. It's a very important, because for example, when you look at risks generally in the workplace, when you start to pick out it, maybe from the level of confined space, work at height and all that, we should be able to carry out a kind of cost-benefit analysis. Now, one thing I've got to understand is that most of the top management, they don't want to hear this whole thing about hazard, accident. And now the approach that we are going with the modern level of professionalism, that is why the ISO 45001 did not specify only on risk. Because if you look at OSAS 18001 or thereabout, was only talking about risk, but 45001 talk about risk and opportunity. Okay, so this is the idea. When we bring things to the management level, we need to, as we present the risk to them, we also need to present the opportunities that comes when you prevent risk. Okay, when you're able to manage risk, okay, within our work environment. Like I've said earlier, cost-benefit analysis is very, very important. These are special skills that we must learn at our level. We should be dealing at a strategic level. Okay, because when your company know your level of expertise, when you speak, believe me, they will listen to you. I don't know if you get what I'm saying. When they know your level, when you speak, you say anything, you need to give contribution, they want to listen to you. They want to hear what this guy has to say because of the level of information you can carry. And I believe at this level of our professionalism, we should be able to say, yes, when you do this, then we should be able to convince them that, yes, you are going to spend money getting this equipment. You are going to spend money training the workers. But in return, we have to prove to them how they can make profit, return on investment, because they might have this conviction that, yes, they are going to spend a lot. But it is our own responsibility to make a research and come to them and present to them that, yes, even if you spend 50,000 Qatari riyals to establish all this prevention, you can make a return of investment of even 100,000 Qatari riyal or even 150,000 Qatari riyal. There is no human being, there is no businessman who will come and present such to that he will not buy. That is the reality. So for me, and for us as a professional, we should be looking at those areas which we can dig out to bring evidences, to be able to convince management. You first of all prevent, as we are dealing with them, we first of all bring out the opportunity, we bring out the benefit first before presenting the disadvantage to them. By the time you start presenting the disadvantage, some of them will start, oh, what is this guy saying? So this is just my little contribution on how to be able to penetrate senior management within any organization we'll find ourselves. Though we have some crazy organization that things does not even exist. So, but we just keep pressing and continue to send mails, quoting those references and all that, because we know most of us, we have different background. I have background I've come through as a safety professional. There are some company you find yourself, man, you just discover that you are just the one doing everything. So, and for you to also save yourself based on the environment you find ourselves, because if it's in the US, you don't need to beg them. We know things are strict in Qatar, but then people still violate. Some companies still violate a lot. But in the US, in the UK, we know how powerful their inspecting institute work, to bring down a lot of employer. I know that cannot be compared to that of Qatar, but I know Qatar is still trying. But then, if it's in all those countries, we can just not stress ourselves that much. But in the environment we find ourselves, sometimes you find some the way some people will say Alibaba companies, but we just have to save ourselves also and do the needful to make sure that we communicate with them so that whatever happens at the end of the day, we have evidence to save our head as a professional. Thank you very much.
Thank you very much, Mr. Stephen. I appreciate that that contribution. That's also to portray what Mr. Andrew have said. Everything starts and most times ends with the management. If you have the total support of the top management, then implementing these procedures will be very easy. It will be like the easiest thing you will do. But if the management have not bought the idea of this procedure, then you will struggle to make an impact. Okay, so we'll start from the management while you are building your health and safety culture with the employees. Also ensure that the management is at the forefront of the implementation. Okay, Mr. Liberty is raising his hand. Let's give him the opportunity. You can unmute and start speaking. Liberty,
okay.
Go ahead.
Okay. I think you
Okay, Mr. John.
Yes, I changed to another gadget. That's why you're seeing Liberty there. Guys, unfortunately, I'm sorry I'm not able to show my face and then to also display the document because just some few things I just wanted to add. Is that okay?
Yes, it's okay. Go ahead.
Okay. So thank you so much, guys. At least I joined from almost the beginning. I was able to make it, to participate and to hear all the lectures that have been given. Mr. Johnson, thank you for this opportunity, and Francis, and the other guy who spoke. Unfortunately, I'm the only grad-diverse guy. So when we speak, we have to be careful, however, I'm going to just make a little contribution for a few minutes. And currently, I work in the oil and gas. So I am privileged to know a little bit and some procedures that are a little bit higher, or how will I put it, a little bit stronger than the way it is done in construction, just like Francis and Johnson has mentioned. In the oil and gas, they are a little bit strict, or they are not a little bit, they are more strict when it comes to confined space. As a matter of fact, confined space is considered as life-saving rule in Qatar Gas, or let me say in Ras Laffan. So they have about 9 saving rules, about 10 life-saving rules. And according to Qatar Gas procedure, if any of these 10 life-saving rules is violated, if it is investigated and you are found wanting, there is nothing to talk about. You'll be outrightly removed, regardless of your position, regardless of, even if you are the construction manager or the project manager, you are gone. And confined space happened to be one of the, among the 10 life-saving rules. So I'm not going to do the definition anymore because everyone have spoken about, I've mentioned all of that, Johnson and Mr. Francis. And I'm also going to talk about other things that you guys have, but just few things that would bring more light to the confined space itself. So I'm going to talk about confined space entry. When do we say someone is considered to have been to have entered the confined space? And it is when someone has broken into the place of entry and into the plane of an area deemed as confined space with any body part. This is very, very important. That is why I wanted to highlight this information. With any body part close to the breathing zone of human, including putting one's hand, one's head or torso into an open manway. It is all considered as a confined space entry. That is, if you are standing near, for example, in a manhole, for example, and then your hand has entered or your head, you know, it is considered you have entered confined space. And so the procedure or the control measures that ought to take place or that are carried out within a confined space is applicable to you. Means that if you are someone who's working where they are working in a confined space and your hand or your leg or any part of your body gets close or enters into those positions, you must comply with confined space. Else, you have violated the confined space procedure and you will be removed from the project. This is how important and how strict they are. And then again, another definition or another important information they have added to confined space in the oil and gas or in Qatar gas project is that it's any space which has 1 meter or more in depth is considered a confined space, including open top space. So, for example, an excavation that is 1 meter deep is considered confined space. People working in a ditch, workers who goes to the ditch to clean the ditch, like, you know, I mean, the general word we're familiar with is gutter. You know, a gutter that is 1 meter deep in oil and gas is considered confined space by this definition. And it means that all confined space procedure must be applied, must be put in place. That is permit to work, system, hole watch, gas test, and all of this must be done before that activity can take place. You know, is that clear? And then one other thing that I want to say quickly, I don't think there is, well, I'd love to talk about some of the roles and responsibility, you know, specific roles and responsibility, but there's no more time. Maybe another time if the opportunity presents itself. So I just wanted to add this little parts to what we have all said. Thank you very much.
Thank you, Mr. John. I appreciate that contribution. And you see the way I was smiling because I know one person alone might forget some points, and this type of discussion coming from different industries will open the eyes of those that are not in that industry to understand how it's done over there. So we appreciate you. Thank you for that contribution. I'll give the opportunity to Mr. David to contribute. Sorry for keeping you waiting.
Not at all. Thank you very much. Sorry, can you guys hear me?
Yes,
Yeah, sure.
I hear you. Go ahead.
All right. First and foremost, I would like to appreciate the first two speakers who actually made a brief presentation on the topic on hand. They actually did justice to it. In fact, they just gave us the ABCD of a confined space. And to the last speaker, I also appreciated you bringing your oil and gas background to this discussion. However, everyone has said a lot regarding the topic at hand, but I will only be asking questions since the topic has justice has been done to the topic. So firstly, my first question is this. From the definition that we got, it said the confined space is defined based on the 3 categories or criteria, which of course limited spaces, space large enough to be bodily entered, and unfavorable atmospheric condition. So my question is this: must is it the 3 criteria or 3 conditions that must be met before we can say this place is define a space as a confined space? Or if one of these conditions is present, we can say yes, it's a total confined space. That's my first question. My second question is, there are different types of confined space. There are some that are in service, and there are some that are newly constructed. So I'm considering an in service. For an in service, of course, they have to make some isolation, bleeding, flaring, and all of that, cleaning and the rest. So I would like to understand the word positive isolation. What is a positive isolation in a confined space? Okay, that's my second question. Then lastly, my third question is, what is the minimum allowable current voltage in a confined space for an equipment, for a power equipment that should be used inside a confined space? Maybe let's say a light, because like we've pointed at, one of the one of the hazard of a confined space, poor illumination, right? So of course, definitely they will have to provide a lighting system. So what is the allowable or permitted current voltage that should be allowed inside a confined space? Thank you. The question is open to everyone. So anyone can answer any of these questions, just to clear the air, because from the discussion, I realized that I think these 3 areas wasn't really clear or touched. Thank you.
Okay. I think Mr. John will do justice to the first and the second question.
Okay. So the positive isolation, and what are the questions again? Please remind me. Sorry. Let me.
Okay, sorry. Yeah. One of the question is, what is a positive isolation in a confined space activity? Okay. Then the second question is, what is the voltage, minimum voltage that should be permitted, that should be used inside a confined space? Because it's not all voltage that you can actually use inside a confined space, considering the fact we've identified that is a flammable material or fumes, of course. So not all voltage allowed. We just want to know, is it 24 voltage is permitted? Is it 222 voltage? So what is the minimum as per any standard or any standard or procedure?
Let John answer the ones. We'll come to those ones gradually.
Let me answer the voltage, because if I could remember, according to OSHA standards, I think you should have I think around 12 or less, from 12 volts and less. This, according to OSHA standard, if I remember, because I know from 12 volts and less is what is allowable according to OSHA. Because there's an incident that has happened in Qatar also, which it came as a result of high voltage lighting system in the confined space, and that thing caused a lot of people finished there. So I think I could still remember that, because that was what made me read it then. Except maybe there's a change. But at the time I checked, I know it was 12 volts or less. Do I stand to be corrected as well?
Okay.
12 volt for AC, 12 volt AC is allowed. Okay, John, continue.
Okay, so I will just talk about positive isolation. Now, positive isolation is actually supposed to be discussed under LOTO, logger tagger, actually. Positive isolation is when you ensure that in a vessel or in wherever you are working a pipe, okay, or in a liquid, that there are no hazardous material to enter that work area. You have demonstrated, and you are able to demonstrate zero energy. You are able to demonstrate that there are no possibility of any hazardous material to enter into the work area. That is positive isolation. And you know, when you are discussing or when you're talking about that positive isolation, there are other things that will have to come in place. Like there are single valve isolation, and then there is a blinding. You know, those are all process of logout and tagger. But the simplest way to put it is to ensure that there are no hazardous energy, or there are no hazardous material entering into the workplace. That means you have been able to demonstrate positive energy. Sorry, positive isolation. To ensure that in the vessel you are working, in the silos that you are working, or in any of the confined space, it is not possible for hazardous material to enter the place. I don't know if that makes sense.
Yes, it makes absolutely sense.
And in so doing, there is single valve isolation, there is blinding, double blinding, there is bleeding also, there is double isolation. So it's a whole lot of process actually. It's supposed those are procedures that are actually carried out in oil and gas, you know, and especially during LOTO, you know, because the logger tagger procedure in oil and gas is huge. It's a huge procedure. It's a huge thing that, you know, a lot of things are involved, you know. So I don't know if that makes sense to the guy who asked question.
All right. Thank you very much. It makes a whole lot of sense. It makes perfect sense. And the reason why I asked this question was because you know, you came in and you, of course, shared your oil and gas background. The thing actually is that let's take, for example, we have a tank, an oil storage tank, for instance, and in this oil storage tank, they want to perform a rehabilitation or carry out a maintenance.
Yes.
And before they have to carry out this maintenance, of course, there have to be planning, preparation, and part of the preparation of first stage would be to drain out maybe the remaining residue, right? And cleaning, and of course, doing their purging and all of that. So once that is done, they need to ensure zero energy. And how can they be able to achieve this? Is to perform the positive isolation. The word positive isolation is a very critical terminology used in the oil and gas. So it's just for us that when we're dealing or discussing this topic is to understand that word, because most times during interview, they might ask, what's a positive isolation? I've met cases like that several times where they ask that word, what's a positive isolation? They just want to know. If you are able to explain it well, then they understand that yes, this person has a very good knowledge about the confined space, you know, isolation. But the thing is, when implementing the positive isolation, is being implemented with the LOTO procedure, right? Which is, it could either be the electrical or mechanical isolation. So for mechanical, like you said, the blind, the spade, that is when you want to blind, cut off, disconnect the pipe that is connected to the flange of the tank. So when you disconnect completely and you blind, you isolate the flange on the tank and also isolate that of the pipe, and also disconnect maybe the transmitters, any instrument that is attached. Then positive isolation has been implemented. So that's what I'm trying to drive home at. So thank you very much. you are 100% correct. Makes the perfect sense.
Just to add
Absolutely.
to what you say, currently we're carrying out cleaning of sedimentation tank. So in our project, we are also doing microtunneling because we are laying pipe from the sea and connecting it down to the plant. And while carrying out microtunneling, because the pipe we're laying is about 10 meter, deep. So we are digging, and there are roads, there are facilities already available. So microtunneling process have to be in place, and we are doing that. And then some of the while doing the microtunneling, there are a lot of oil, there are a lot of contamination that is ongoing. So you cannot discharge, the slurry into the ditches that's available, where waters are allowed to, when they watch the tank, usually weekly or monthly maintenance of tank, and release the oil and water and everything to the sea. So we have to confine the slurry into a sedimentation tank, and it's huge. So currently we are carrying out, we are ensuring that tank is completely purged of any energy, anything, because while people want to go work there might be possibility, because this slurry, it comes with a lot of contamination and everything, and it's stored for some while now, like I think from the beginning of the project. So you can see. So that is exactly what you are explaining. So going into, that's why I said it's actually under LOTO. I think maybe if there is an opportunity again, we will discuss some of these procedures in oil and gas as it has to do with log out and tag out, and some of the process that you just mentioned, like this positive isolation, demonstration of zero energy, blinding, and all of that. Thank you so much for that question.
Okay, thank you, Mr. David and Mr. John. We are glad to learn a lot from the oil and gas procedures. There's one question that is left. He said he asked if the 3 criteria must be met before it's considered as a confined space. Okay,
not at all. The 3 criteria must not be met. The definition so far that has been given, once one of the conditions is met, it is considered confined space. And like I have added from the oil and gas, if you are digging, carrying out an excavation, and it's 1 meter below, it's already confined space, considered confined, even though it's an open, because what from construction background, what I understand about confined space is an enclosure where it is not designed for human occupancy for a long time and all that. But and there are chances of what do you call it now? Engulfment and all that. But so in oil and gas, even though it's an open excavation, it's an open excavation where people are standing, just, I don't know if you can, just the measurement of your leg to your waist, or maybe or less. Once it's 1 meter, it doesn't matter. It's already considered confined space, and all the procedure must be applied.
Sorry, 1 minute to add to what he has just said. There is an incident, this question just brought it out to me. There was an incident that happened in Abu Dhabi some years back of a confined space. And when you look at this space, though it's a confined space, because for me, the only criteria that made it a confined space was that there was no proper ventilation, but the entry and exit was large enough.
Yes.
You get, was very large enough. But one of the criteria that could not be met was it was not properly ventilated. And it was very big and massive. Like, it was very big. You just wonder, how can somebody go inside this place and die? The moment this guy went inside, the fellow workers, about 3 or 4, went with him to rescue him. All of them, they died inside. This is a live incident from Abu Dhabi. If I had known since, I would have just done the video and shared with us. So it's a very big thing. You might just think this is not a confined space. So that is just it to have to read.
Yeah.
Yeah, thank you for that scenario that explained it all.
And in addition to, well, anyways, there's no time, because apart from permits that is implemented while working in confined space, you must also obtain a confined space certificate, and it has a lot of requirements, Anyways, there's no time now.
Yeah. Confined space in construction industry, I will say that we are just joking. Yeah, I will say that we are just joking. You will even you will find the execution team arguing with you on the manhole to implement a confined space. So that is we need to go and learn from oil and gas.
When you go to the role and responsibility, that's when you will really understand that they are not joking there. The operating party and the performing party, these people, their responsibility is key. And once you are designated to carry out any role, to play any role, that is the only job you are doing. You are not doing any other thing. If you are assigned and you have been appointed as a whole watch, in fact, as a matter of fact, for you to even become a whole watch, you must be trained, third-party certified, and that is the only job you do. And the authority a whole watch guy has, like something happened today. We had a walkthrough. I'm sorry, guys. This is important. We share all this experience. So we were on a walkthrough today. We do our walkthrough every Thursday. Vision of clients and contractor, subcontractor, and everybody. So we went on a walkthrough, and part of the place we're going for inspection, we're entering a confined space, and so I don't know, but no, the guy did not do this deliberately. It's actually the lead HSC, the HSC lead for Katagas, for this project, and we all went because, of course, part of the things I wanted to also discuss, while you are entering a confined space, you must also be trained. You must be trained, and your training card must be updated. It must show, it must be valid, because like last year, my training card this year has expired. I will have to go for that training, 7 days consistent training. It's PSI, plant safety induction training. You have to, and it has to be updated on your card. Once it's not updated, once it expires, in fact, as you are crossing a particular gate, you will not be granted access. You just place the card and it will not read because your training card is not updated. It means you have to go for training. So we had submitted all our cards and we are about to go. This is a worker, a labor, but he is a whole watch, and so everybody was just going, and then the HSC lead, he actually forgot his toxic clip. Of course, it's part of the equipment we use to detect gas and all that. It hung close to the chest, on your breast area by your right hand. You hang it there. So the guy did not have his toxic clip, and I was shocked. This guy, the way this labor came and pulled this guy out. And guess what happened today? They awarded the guy on Sunday. This guy is going to receive an award from Kataga's head of projects because of that singular act. The HSC lead, he pulled him out, and everybody were shocked. That is how powerful and the level of authority they have given to these people. Because if anything goes wrong there, he will be held responsible. So it was so funny actually. But the guy had really written his name in gold in Qatar gas project, you know.
It's interesting to be in the oil and gas. Just open ways for us. Let's come and join you there.
Oh my God, that's the place to actually work at safety, because you really enjoy it. Because I mean, there's no headache. You like not that there's no headache, but the point is that everybody
has the responsibility.
Compliance is not negotiable. It's not negotiable, regardless of who you are.
Yeah, compliance is not based on your level.
No.
Yeah, we appreciate everyone for your contribution today. I've really learned a lot from you guys, and I'm sure that you learned a lot also from us. So this is part of the game. You know, if we discuss one topic on each week, we are refreshing our memory on that topic. So it's part of reading also. So if maybe you are asked to read for 1 hour, you might not be able to sit for 1 hour and read without getting distracted. But for 1 hour, we've been discussing this topic. We've been taking in a lot of information. So it's a plus to us also. So I appreciate everyone, and I thank you for keeping a date and a time with us. So next Thursday, we'll discuss another topic. If you have a topic in mind that you want us to discuss, just send to me privately so that we would discuss it together next week, Thursday.
Okay. Thank you very much.
So much. I just really want to appreciate you for this platform. You are really encouraging a lot of persons, and you know, just like you just said, when we come together to talk about things like this, we learn, you know, things you seemingly must have forgotten, you learn it, you know, and it's really good. And a lot of people that will stumble into this video, I'm really going to encourage you, if you're hearing me, please go to Safeoclock.
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 Yes.
Safeoclock. Visit Safeoclock on LinkedIn and on YouTube and on Facebook, and do yourself good, because some of this information we are giving out freely here, they are learnings and training we have undergone. We paid a lot of money and time to acquire all of this knowledge, and you're going to get it just at the tip of your finger, you know, by just going through Safeoclock platform. So please do yourself a favor by visiting this platform on a regular basis. Thank you so much, Mr. Johnson.
Yeah, thank you very much. Like I've said in the flyer, I'll be giving CPD certificate to anyone that needs it. Before we started, we were able to have registered the Safeoclock with the Corporate Affairs Commission Nigeria. So we'll be giving a certificate based on that. We are Nigerian based. So anyone that needs a CPD certificate to update his CPD in IOSH or IRSM, you'll get it from there.
That's cool.
Yeah, thank you very much all for coming. We'll see you again next week.
Thank you. Bye.
God bless you all. Bye.
God bless you. God bless you.
Thank you very much.
Thank you very much, Dave. It's time to sleep. You can sleep now.
Sleep don't come up for you.
Try and sleep.